Alright, welcome to example 5. Prove that the following triangles are congruent. And you are given some information. You are told that AB and CD intersect in O. You are also told that AO is equal to OB and DO is equal to OC, and you must prove these two triangles congruent. Now in this question you'll see that you will have to now use your geometry skills. What we mean by that? Well, firstly, when they say AB, that means this whole line is a straight line. It means it's a straight line. And CD, it means CD is a straight line. It means that these are two straight lines intersecting in O. Right? Now, if they are straight lines intersecting in O, then you have to recall some theorems that you have learned before. So I hope you are recalling the theorem. So there's a straight line, and here's another straight line. They're intersecting in O. So you have to recall a certain theorem. Well, I hope you recalled the theorem vertically opposite angles. Angles are equal. Before you can say vertically opposite angles are equal, you've got to be sure that this is a straight line and that is a straight line. We are 100% it's a straight line because they said AB and CD. Therefore, that angle O1 will be equal to that angle O2. It was not given, we are writing it down. So we will go there and write that this is X and this is X. Now, let's see what else. We are told that AO is equal to OB. AO is equal to OB. And then you are told that DO is equal to OC. You are told that this is equal to this. And now you study the diagram carefully. You study the diagram carefully. You can see you got a side, angle, and a side. You got a side, angle, and a side. So, in this example, you are required to prove triangle AOD is congruent to triangle BOC. When they write the sign here and they write the name here, then it is already in the correct order. Then it's already in the correct order, but you can always verify it. AOD goes 2 strokes, X 1 stroke. So the next triangle will be 2 stroke, X 1 stroke, BOC. That's why this is BOC. Proof. 1. AO is equal to OB, that was given to us. 2. DO is equal to OC, that was also given to us. But this third one, O1 is equal to O2, it was not given to us. We have found them to be vertically opposite and they are equal. So, this is the case is side angle side. Therefore, triangle AOD is congruent to triangle BOC, and the case is side angle side. Now, they didn't ask us to write down the deductions. They didn't. But I will just do it, right? I will just do it. Let's do the deductions. 1. We'll always do the angles first. Angle A is equal to angle B. Is that used here? No. So it is a deduction. Angle A is equal to angle B. 2. O is equal to O. O1 is equal to O2. That's already used here. So it won't be a deduction. D is equal to C. Is it used here? No. So angle D is equal to angle C. We are finished with the angles. Now the sides. Clearly, AO is equal to BO, that is used here. Can you see that? OD is equal to OC. OD is equal to OC, that is used here. So those can't be deductions. And finally, the first to the third is equal to first to the third. AD is equal to BC. AD is equal to BC. So AD, this line here, is equal to BC, this line here. And finally, area of triangle AOD is equal to area of triangle BOC. Area of triangle AOD is equal to area of triangle BOC. So, in this example, we're showing you that everything will not be given. These angles were not given. And we had to use our geometry and find that answer. So, there we are. Alright? So, some things will be given in some examples and some things will not be given. You have to use your geometry and find out what are the other equal angles or equal sides. Alright, so if I take another color and just mark what we deduced in the diagram. What we deduced, we found that angle A is equal to angle B. We found that angle C is equal to angle D, and we found this side is equal to this side. So sometimes after you do the deductions, it is nice to mark what you deduced. Mark your deductions inside there, like that. Now it's very interesting, although they didn't ask you here. Now you can see there's some very interesting development. You see this angle is equal to this angle. These are alternate angles. Therefore, that line AD is parallel to BC, converse of alternate angles in parallel lines. I'll repeat that. You see, Z is equal to Z. These are alternate angles. Therefore, AD is parallel to BC. You can use Z and Z, or you can use Y and Y, and now conclude that AD is not only equal to CB, AD is also parallel to CB. So I'll just mark it. As a student, you'll find those lines are now parallel. And that's how congruency becomes useful, because only after proving congruency you were able to prove these angles equal. Only after proving these angles were equal can you prove that the two lines are parallel. So one thing leads to the next, leads to the next. So that's why geometry starts getting more and more interesting. Alright, thank you very much. That brings us to the end of congruency. And what we're going to do now is we're going to give you an exercise which you can try and have fun. Thank you very much.